ョン、はい、今、表示されましたけども、はい、一応、参考までにレコードをさせていただきます。この後、今日ご参加になれない方もいらっしゃるということを聞いておりますので、その方々のために一応レコードさせていただきますので、あらかじめご了承ください。一応、この参加でもって、レコードに同意されたということを皆させていただきますので、どうぞよろしくお願いいたします。えーっと、今日はまずこの遅い時間、日本時間の遅い時間になりますけれども、まずはご参加いただきましてありがとうございます。私はボッシュ株式会社で、いわゆる技術戦略を担当しています、森田と申します。で、私のポジションとしては、一応、COVESAの中で、標準化活動、いわゆる VSS とか、そういったところのですね、ボードメンバーは別にドイツ側におりますけれども、そこの日本で一応ワーキングレベルで一応担当しているものとなります。はい。それで、今回ですね、このCOVESAで、今活動しております、VDM っていう、VSS の次世代型の、バージョンだというふうに言っても差し支えない。この後担当者の BMW のダニエルからちょっと説明がありますけれどもですね、今、現在、API の標準化活動、日本でも、今、今回ですね、JASPER と OpenSDB イニシアティブ、双方にお声掛けさせていただきまして、他にも多くの方に、私からもお願いさせていただきまして、今回、セッションを開催という形に、COVESA主催で開催という形にさせていただきました。で、API 標準化に関してはですね、今、COVESA の VSS っていうのが、よく皆さんご存知かと思います。Vehicle Signal Specification ということで、活動が進められているっていうふうな認識を皆さん持たれているかなと、実際に活動されている方も大勢いらっしゃるかなというふうに思っています。実はCOVESAではですね、その次世代版というかですね、そのモデリングの仕方につきまして、相当の議論を重ねてましてですね、この度、新しくビークルデータモデルっていうプロジェクトを立ち上げました。で、今回、その VSS とその VDM の関係ですとか、今回ですね、今後ですね、実はこの再来週ですね、COVESA オールメンバーミーティング、デトロイト近辺のアノーバー、US、アメリカで開催になりますけれども、そちらで改めて具体的な説明がございます。で、私も実はその場に行きますけれども、日本からぜひ参加される方、もしいらっしゃいましたので、ぜひそちらに参加いただいてですね、そちらで詳細なことは聞いていただきたいと思っております。で、今日はですね、せっかくのこの時間ですので、こういうバーチャルな形でですね、なぜこの VDM っていうプロジェクトが始まったのか、その背景からですね、やっぱ VSS の違い、一番聞かれたようなやっぱ VSS との関係でどうなるの、VSS って残るの、基本的にはVSS と基本互換関係をうまく取りながら進めていくって、そういった形にはなります。ですが、一応、背景、違いですね。なぜ VDM を導入するに至ったのかっていうところについて、ダニエルからご説明差し上げまして、おそらく30分ぐらい、ご説明を差し上げていきたいと思います。英語になりますけれども、あらかじめご了承ください。でそれから、おそらく字幕今表示されますと、おそらくイングリッシュもしくは、多分トランスレーション、翻訳が機能がこの Zoom 内で機能できて、日本語でも字幕でご覧いただけるかなと思いますんで、もしちょっと英語不都合ありましたら、そちらをご覧いただく、けるといいかなと思います。で、あと、もし、この後 Q&A セッションも設けますので、その時にもし英語で質問しづらいということがございましたら、私に日本語でおっしゃっていただければ、私はトランスレートいたしますんで、その辺、サポートいたしますんで、どうぞよろしくお願いいたします。はい。では、ここからプレゼンテーションに始めさせていただきますんで。So, Daniel, so now I've done the introduction, brief introduction and some greetings in Japanese. So then you can start your presentation with some introduction of the VDM project. So, thank you very much.
Thank you so much for the introduction. I wish I could do it in Japanese, hopefully one day. But today we will present the topic in English so that everyone can follow. I believe that there will be interest in different areas that might not be covered in today's presentation. If that is the case, feel free to just get in touch. We are quite open and willing to extend this initiative to something much bigger, and especially also with the increasing interest from the Japanese market, extending this to an initiative that can be also reused in the Asia market would be very interesting for for the COVESA Alliance, where is this data model activity hosting. So just for those who don't know me, my name is Daniel Alvarez. I work for BMW for a few years already, especially linked to the data modeling activities. And what I will present today is, it has an acronym. It's called the VDM, which stands for the Vehicle Domain Data Model, or simply Vehicle Data Model. So I will cover the overall, the general overview of what we mean by this, what is the scope, what kind of artifacts, and so on. So I assume in the end we will have some space for questions. If you would like to know more, I will be willing to address them. So this data model basically covers not only, or is intending to cover not only the in-vehicle generated data. By these I mean all the observations that are coming from the sensors. Some people refer them as signals, some other refer them as properties or data streams from the vehicle. So the idea is to cover not only this in-vehicle generated information, but actually extending a systematic approach that can be reused to other areas that are also important for the vehicle. So in this case, you might have person data, cloud services, infrastructures, charging stations or gas stations. You might have also like other types of mobility services or infrastructure from the city. So actually the scope can be endless, and in the context of the alliance where this initiative is being hosted, we don't have a fixed scope yet, so this is still to be decided. And of course, the members who decide to participate can also help steering the scope of action for this data model. But as a rule of thumb, the idea would be to focus this model in the open, just for those aspects for which these subject matter experts can contribute with the information in order to extend the data model and also to maintain it, right? So it doesn't make sense to model every single domain that might be relevant to the vehicle if you don't have the people who is contributing to that, right? So this is not fixed, but it is still under discussion. Good. So I assume that some of you might be already familiar with VSS, which stands for the Vehicle Signal Specification. This is a control vocabulary of high-level vehicle properties that has been maintained for over a decade in the COVESA Alliance. So basically it means that you describe and formalize aspects like the speed, the acceleration, the steering wheel angle, the window position, in a way that is easy for non-experts in the electronic system of the car to understand and to reuse it. So that has been the purpose so far. So how this activity is related to this VSS? So there are two aspects that require attention. So one is that the existing specification for those people who have been working with the VSS, the information that is already formalized can be kept. So it's not mandatory, it's optional. You can decide to keep the information fully as it is, because VDM is not only covering the scope of VSS, but VSS can be thought as one source of data. As I mentioned before, then you can extend with other models for the person, infrastructure, and so on. So VSS can be imported in this methodology as a one source that can be included here. Second aspect is that this data model for the vehicle has a similar operational mode. And by this, I mean that we can at least identify these two different areas in where the systems are implemented. When you think of a concrete database, a streaming framework, or an application, this basically is residing in the physical layer, right? But the purpose of having an abstraction of this is to have a unified formalization of the concepts of interest that are used in the physical layer. So the idea of having a model once and then use it everywhere you want is basically what is aligned with the so-called data-centric architecture. And this is where the modern architectures in multiple enterprises are heading to, right? So long story short, the idea is that you specify the domain, and then by some tools, you can reuse this specification in the shape that is needed in the physical layer, right? Another question that I get asked a lot is how this VDM is different from the VSS. So there are several aspects by which one can compare them, but I selected here the main ones. When you think of the structure of how the information is formalized in the current vehicle signal specification, basically you have kind of a tree hierarchy where you define branches. This can be the vehicle, the cabin, the door, and so on. So you have one hierarchy where you classify the information in one dimension. In contrast, in the VDM, we are using a language that is meant for a graph. So it's kind of a semantic network. And this means basically that you are not constrained to just follow one tree. You could if you want, but the idea is that this resembles the way how we represent our knowledge, which is basically interconnected entities, where you have basically the freedom of connecting the dots the way you need them, right? So this is a very important difference. Then the modeling perspective. So since you have in the VSS1 tree, this means that anything that you are modeling in this domain will be from the perspective of the root node downwards, so top down basically. Whereas in here, you can basically model from anywhere. So if you are interested only on, let's say, a charging station, then maybe your entry point will be here. Whereas if you are interested in person, then your entry point might be here. So you can basically have anywhere perspective, so to say. Another difference is the modeling language that is behind this formalization. So the VSS project uses so far so-called VSpec. This is nothing more than a YAML-based format with some custom constructs and syntax that is meant for representing aspects like the unit, the data type, the description, and simple metadata that is useful enough for simple formalization. In this domain, so in the VDM, we are reusing the GraphQL schema definition language. So I assume some of you might be already familiar with GraphQL ecosystem or might have heard about it. The idea here is not to impose the use of an API of the GraphQL ecosystem, but rather reusing the language part in order to specify the semantics, the meaning of the domain. Yeah, so the focus is on the schema definition language. And the difference is that this language is already a standard in this ecosystem. It has also a decade-long history, but the community is much more bigger, and it's much bigger beyond automotive. So it's not only meant for this industry. So that's also a plus. And then the scope. In the current VSS, mostly the data that is specified, it relates to aspects that are coming from sensor measurements most of the times. So we might say that in-vehicle generated data is the main purpose of this. Whereas in here, the idea is to extend this to other subdomains that are related and importantly, like they are also important for the vehicle or like the member organizations that work with vehicle data. Good. To be a bit more concrete about the operational mode, there is also another important difference between VSS and VDM. If we take the reference VSS, VSS basically is offering you two artifacts. So on one hand, you have the resulting specification. These are basically a collection of files that are written in this language called VSpec. And this is result of applying a certain rule set, a certain modeling guideline. So basically, this is a second artifact that is offering COVESA, the COVESA Alliance, is the modeling guideline together with some tools that are understanding this language. But what you see in the open basically will be the collection of data points for which multiple organizations have agreed upon, right? So this is kind of the setup as a zoom out view of it. And in contrast, we see that the VDM basically follows a similar setup for what you see here on the right side, but the difference here is that this part on the left is already existing. So this is based on existing standards, namely the schema definition language and some extensions that are based on the semantic web, like vocabularies that let you do some other stuff that is useful for other uses, right? Then the tools around them are also stable or relatively stable. So you have like libraries that are reading, for example, RDF data format or GraphQL format in multiple programming languages. So the approach is based on established standards. Good. So this approach, the VDM, is based on, if I go back one more time, sorry about that, it's based on this simplified semantic data modeling. So this is basically just an approach that is telling you how you can model the domain in order to be aligned with the existing standards and how you can use that with support of existing tools. Right. So the idea is to have a simple method that let you do this modeling. So let me just jump to another presentation that is explaining in more detail why we need such a semantic data modeling in a simplified way. Good. Can you please confirm that you can see the presentation I changed to another one?
We can see it.
Okay, good.
Yeah, I can see it. Yep.
Good. So let me mention the reason behind this. And as you know, this is a project that is coming from the COVESA Alliance. If you're not familiar with this, basically there are around 90 member organizations that are participating in collective artifacts. And this is a good opportunity in order to bring up some, let's say, interoperable artifacts, but at the same time, it can be a challenge to get to an agreement. And semantic data modeling is a core part of it because there are other projects that depend on that. So why we need an upgrade to the language and also a simplified approach can be seen by going one step back and mentioning what the VSS current language is. So in this case, we have an example of a specification for a data point that belongs to the charging domain. And in the end, what you see in your Git repository, you will have several files that are following a YAML-like format, explaining aspects like data type, let's say like the allowed values and so on and so forth. So it's quite simple to understand, right? Then if you apply this language systematically, you will end up with a collection of properties in the context of the VSS project. In the open repository, there are around 750 unique concepts without considering the instantiations. And you might argue that this is not a huge number, but it's important to mention that this number is basically properties that many member organizations have agreed upon. So having agreements is often challenging, but this is kind of a common set of concepts that like the member organizations can reuse out of the box. But what is important to note is that in the organizations that are using this, you might encounter that the concepts are in the order of thousands, right? So it's something that you cannot fix in one shot by reworking the language and then just making it more explicit, but you need to have a different approach, and that is what we are trying to do. And as I mentioned, this project has a decade of history. And the thing is that the requirements have changed over the time. And this imposes certain concerns and challenges, at least to mention three of them. Basically, we have the data-centric adoption gap, we have a problem-driven motivation, and we have an operational concern. And I'm sure that some other organizations apart from BMW are facing similar challenges. And this, what I will present in a second, will resonate maybe with some of the challenges that you guys are addressing. So let me just explain what I mean by each of them. When it comes to the data-centric adoption gap, and this is particularly true for big companies, for large organizations or enterprises, where you have multiple systems, or maybe there are few decades of history in the IT, you will have several legacy systems, and you need to align the terminology in order to get rid of the data silos. This is a non-trivial problem, right? So there is concept of a data-centric approach that ideally tells you that you need to curate your terminology top-down. So that means that you will have common terms that are used in your company, like saying, what do you mean by a car? What do you mean by a building, by a person? All these terms that are reused everywhere. Then you have categories that are domain specific, and this is where most of the vehicle activities related to VSS are located, in which you will specify sub-branches like the battery or like the door and so on. And these can be growing in the order of thousands, as I explained to you before. And the last part at the bottom, you will see the assertion box. This means the instance data that is persisted in your system. It could be a database, it could be in memory, located in a variable in the application. These will be instantiations of the terms that you have. The problem arises when you need to do a change. So you need to change something, you need to fix a problem. What happens often is the completely opposite to this ideal solution, right? So it's not going top down, but it's going bottom up, because a developer is changing the variable name, is changing maybe the column in a data set, or is changing the schema in the database without replicating these to the upper layers. So this is causing basically the disparity in the data models. And what COVESA has been doing basically is trying to serve as a bridge with this simple methodology of formalizing a domain in a way that is not only human readable, but also machine readable, right? So what I call the middle out approach, or let's say a pragmatic approach, something that is bringing value out of the box or much faster than going the ideal way. The point is that BSS, as it is today, is not fulfilling the complete balance between these two worlds. So on the left side, you have the ideal data-centric approach, which has a lot of semantic rigor. That means that you model the domain in the way they should, following best practices. And on the other side, you have the practical use of it by experts, by developers, by data scientists, and so on. And this requires attention, because going one way or the other, you will see an immediate effect, at least in three areas. Like the adoption effort will be high if you go to the left, whereas it will be much lower if you just keep changing things in the application layer. The same or similar aspects are applicable for the development and evolution speed, and the benefit and impact that you can see if you go one way or the other. So this is basically serving as a middleman that will enable you to do much more expressive things, but at the same time keeping the people that work in the application or in the physical layer much aligned to the pace of development. The second concern was the problem-driven motivation. This is because the current way of specifying is limited in scope. By design, it was conceived in that way. It doesn't mean that the language is wrong. By the the design principles that were considered initially, it was fine. But since the since the requirements have changed over the past years, then these languages not enough anymore to express these other things, especially those that you see with the red crosses. And just to mention a couple of examples, you have cross-domain references. If you want to model, for example, a charging session, you will need to combine at least the data from the person, the data from the charging station, and the data from the vehicle. So if you control this only from the vehicle perspective, maybe this is a mismatch if you are exchanging data with the infrastructure, for example. So these cross-domain references are not supported out of the box. And then second example I can mention maybe is the community and tools. So BSS has its own tools today, but the community outside COVESA is very limited. And that means that the tools and also other editors that you might use are limited to the tools what COVESA is offering, or maybe with a couple of exceptions, but it's not something that you can rely out of the box without considerations. And the last concern basically has to do with the language itself. If we use a language that is based on something that is not giving us enough expressivity, so that means it doesn't let you express what you want out of the box, that means that you need to enhance the modeling language. And changing the language is like changing the building blocks of the solution. So that means that the adoption effort will be higher. You will need to have a rework in the tools. And since often is the case that the number of developers are quite limited, so this can become a bottleneck. Whereas what we want is to adopt established languages so that we have a robust foundation, and then we can focus purely on the stuff that comes on top. This means that the adoption effort should be minimized, right? And how are we planning to do this, and how we are prototyping the solution is basically what we have with this VDM model and the method behind it. So the method basically consists on enhancing the way of formalizing the data by adopting standardized languages, in this case, the GraphQL schema definition language, which is checking the boxes for most of the criteria we have listed as important, plus the possible extension, which is optional, to semantic web tools or vocabularies and tools that exist in the semantic web. So just to mention an example, we are focused today on the SCOS, which stands for the Simple Knowledge Organization System, which is a thesaurus-like vocabulary in order to give, for example, extended metadata about synonyms, antonyms, to mention what a concept means in multiple languages, and so on and so forth. So this is very important for data catalog mostly. So this semantic data modeling has been socialized over the last month in some places, including a semantic data modeling conference. If you would like to learn more about it, more details and the reason behind that, feel free to just follow the links. And this is not like an isolated initiative from BMW side, but this is something that has been a collective work from multiple companies. As you see here, maybe some of the names are known to you. So the idea is basically to enable this semantic data modeling in a simplified way, and providing the tools that let you do some stuff. Something like, for example, exporting the specification into the actual shape that is needed in your application. For example, a JSON schema, an Apache Avro schema, CSV export, and so on and so forth. You might also be interested in validating. So that means I am using a model. Can I check whether the use of the syntax is correct? You can also check for constraints. That means even if you have a valid model, I want to know if I am using the methodology in the way it was intended. So you have tools for that. And also automating the registry so that you can host your domain models in a Git repository, and then just automating the pipelines in order to release artifacts, to release exports, to tag the versions of your model, and also to compose models over time with different variants. And you can also like check statistics to know how your model is evolving, and potentially also plotting this. This is still in the to-do list, but it's just as an idea. And also helping search mechanisms for the data catalogs, like being able to pose let's say a natural language query to say I am looking for this property of the battery, and then just getting the candidates and then supporting the data catalogs in this way. This is one example that I can share with you. Right now, the method or this approach is split across 6 different parts. What is important to know that we have 3 different blocks. So one is depicted here with this purple color, which is where the subject domain experts will actively contribute, right? So they need to focus only on number 1. Whereas those that you see in green, they are different processes that will be automated or can be automated using these workflows in GitHub, for example, in order to handle future-proof identifiers, to handle the registry specification, history, and so on. These are aspects that can be supported and fully automated and will be hidden to the normal user, so to say. And the last part basically is in case you are interested in adding some other features that are not supported by this language, like having different ways of classifying your data, or having multiple languages, having synonyms, antonyms, and these kind of features. If you go this way, then in this only case you need to have the support of an ontologist or a taxonomist or someone that knows about semantic data modeling. But this, I assume, will be much more reduced in contrast to what you can control and contribute in this area with people that are not often modelers, right? An example looks like this. You model, in this example, the window position. Using the graphical language, you have a type system, which means I have an object that is called the window, and then I have multiple fields. In this field, I'm calling the position, and this is resolved with an integer data type. So this is the output type. As you can see, is straightforward to understand. It has a very easy learning curve, and anybody basically with little effort can start contributing to this vocabulary. From here, the process that is done automatically, it's basically creating IDs for this. So in this case, you can have your namespace, for example, COVESA or BMW, and then the name of the entity you are identifying, and also the name of the property you are identifying. And then you have the idea of having variants. What do we mean by this is that a window position at this point in time might be realized as an integer, but for some reason then it changed to another data type, let's say a float. And this becomes a breaking change, right? So if you're relying on this information, then your system will crash. And we don't want that to happen, right? Therefore, like the metadata is basically also tagged with a variant ID, which means that for this entity window position, we will have a history that is maintained that says my window has been realized or modified in these different variants, right? And then we can at some point also select the way we want to upgrade this when your system is ready. And one example of the optional extension can be the multiple classification hierarchies. If we take the same entity of a window, then if you consider physical membership, one data catalog might be interested in classifying the window as vehicle cabin door and then the window, or by movement type, like if the part moves or not, and then what type of movement it has. So actually these can be arbitrarily selected because they are use case specific, right? That's why they are considered as extensions. So what is the purpose of this activity in the context of COVESA? Is basically to have a unified, let's say, network or graph modeling approach that let us modify things in a modular way and also in a federated way. So that means that you are not constrained to have your model hosted in a central place. You might have multiple teams working in different sub graphs or sub parts of the whole. And then with the mechanism we are introducing, you will be able to basically cherry pick what we need and selectively construct the artifact you need in the physical layer. So for the context of VSS itself, so the project it's been there for decades, so it makes sense to have a compatibility to this initiative as well. So how this looks in the end is the VSS tools are being reworked. There is a current request for a new exporter, which is being worked today. And this creates the specification you have in this YAML format, in the format that we are working with, in this GraphQL compatible format. And the way back is also possible via the tools that are supporting the export of these files into the syntax that was used before. So that means in the end that if you are using VSpec and you are relying on existing tools for VSpec, there is a way by which you can map back all the features that are mappable to the previous format, right? So in practice, it is nothing more than a text file, right, that is following a syntax. On the left, you see the current state of the VSS with a YAML format in which you have, for example, the branch seed that has multiple instances. And the same information without any loss can be expressed in a different language. And in this example, the seed basically has the same set of properties, the heating, cooling, the height, and you can also add the metadata that is related to that, like the unit, a range, and any other metadata basically is possible to have. An example of the extension might look like this. This is yet another format because the extensions are meant to be semantic web compatible, and in semantic web, if you are familiar with that, everything is around the resource description framework, or RDF for short, in which you have a collection of triples. So this means basically nothing more than saying a seed is a concept, and then this airbag is a concept, and these are also concepts, like heating, cooling is a concept, and then you can classify those concepts. Like, for example, the heating, cooling, or the seat height is a member of that fields collection. So you can group them, and then you can express more aspects on top. So the main benefit you gain out of the box is the existing ecosystem. So there are plenty of tools that are available for this language, and you can, for example, visualize the schemas in a graph, or you can do an automatic documentation of the schema, or why not, you can even build an API if you decide to go the GraphQL API way. It's also it will be also an advantage, right? But it's not mandatory. We are here focused merely on the data modeling. And the same holds for the RDF world, where some tools are also available for visualizing or for cataloging purposes. So in this example, as I presented before, the window is classified here by the part material. which was not part of the main reference or is not part of the VSS, for example, but you can extend it. So what we gain by this is basically three aspects. If I refer back to the concerns, basically this approach is targeting this pragmatic balance between the semantic rigor of the ideal solution and also the usability for subject matter experts. A second benefit that you gain is that you will have more features out of the box. So that means you can, for example, connect entities. You can also benefit from tools that are existing. And lastly, you can rely on something that is stable, that is not changing often, and you can focus the capacity of development on just the added value. So not changing the language itself, but you basically can focus the capacity on what comes on top. And what we are aiming for, basically, if we refer back to the roadmap I already presented, is that so far a subject matter expert requires some expertise in this simple language, so the learning curve is quite easy to follow, but still there is a need to understand a language, right? So once this is established and this is released with the first version, the idea is to focus then on semi-automation of processes with the aim of language models in order to have conversational agents instead of people modeling that manually or with a GraphQL editor, such that you can basically present a conversation to your expert. Let's say someone comes from the battery domain and says, I want to model the temperature, and then via the conversation you got,
Did we lose Daniel or is it me?
Same for me, Paul.
Daniel, I think we lost you.
I lost. Yeah.
Seems to be dropped. Video frozen.
They say he's still on sharing.
This is frozen. Yeah.
Wait a minute. Oh, coming back?
Yep. Now it's okay. I can hear you. So some connection lost. Now it's recovered.
Okay, good.
Daniel. Yep. No,
I
it's
hope
okay.
you could hear the last part. Yeah, so basically, I can show you an example of how this looks like in practice, just to show you how this works. So if we think of the, so I like to refer to this domain because in semantic data modeling, for those who are familiar with the semantic web, in the reasoning domain and OWL ontologies, there is a very famous tutorial about pizza ontology, a pizza semantic data model. And in this case, we wanted to present like how a pizza restaurant can be modeled in this way, just for you to know that this is not limited to OEM stuff or like suppliers, right? So it can be applicable to any other industry as well. So in practice, it looks like this. You might have a Git repository in which you have a specification folder. And in here, you have a modular way of having different entities and the associated elements. Let's say you have a model for the pizza. So you have a type pizza that has some attributes, it has a name, it has a size, and you can also make connections to other entities. So in this case, the pizza has toppings, and then the pizza topping is connecting to some other entity that exists somewhere else. So as you see here, it's not even the same file. So you go to the pizza topping, and then basically it says pizza topping can be one of these guys over here: cheese topping, meat topping, vegetable topping, And in this type system, you can basically model the elements in a modular way and constructing what you want to express. The units are then handled as an enum. In some cases, you might be in the need of specifying the unit of measure. So in this case, you are measuring volume, and then you have compatible units that are controlled with this set of possibilities. Altogether, you can compose these and then just form one big valid schema. And of course, it's not easy to follow, especially if you're not familiar with the language. It will not be easy for you to understand what is behind. But then we can make use of existing tools like the visualizer that is here. And exactly, so here, and there you have, let's say, your pizza concept, which is modeled in this way with some subdomains, let's say. So this is available out of the box, so you can use these kind of tools. Also, you can perform, for example, statistics in here. And in this example, you can say, okay, I have how many enumeration types I have, or how many objects I have in my model, how many interfaces, scalar, and so on. All these are components of the language, so you can have statistics with that. Maybe you can also check that you are satisfying the constraints, or as you see here, it's compliant to the language. If you change something, then in here, let me see what I'm using. From the, let's say you change, this is constraint that you have. If you change this, then it will complain, right? So the tools are supporting you with checking that the proper use of the language is achieved. Yeah, and then the tools also offer some other functions. And as I mentioned, like you can export, you can have a registry supporting functions, you can have statistics. The time is too short to go over all of them, but we are working on training material, because this is being also socialized in the context of the Alliance, and we expect this to be more accessible for newcomers, right? Yeah, I think with that, I will maybe leave open time for open questions. We have still plenty of content that we can cover, but I think it makes more sense to get your view and maybe to just discuss what we can do together, right?
Yep. Thanks for your nice introduction, Daniel. So good introduction to the audiences in Japan, especially for Japan. So I think that this is from the beginning. I think there are many questions, I think, will occur from the audiences, right? So now, please, で、日本の皆様、一応これで説明は終わりにさせていただきますが、この後10分ありますので、Q&A のセッションに入らさせていただきたいと思います。So now time is shifted to the Q&A session. So if there is any questions or comments, some feedbacks, please let me raise your hand. Or putting into the chat.
Hello.
Nishimura-san, please. Yes.
Hello, this is Nishimura speaking from Honda. Thank you so much for the explanation. Very excited. And sorry, I'm not sure that maybe I should do the raise hand on the website, but sorry, I'm not so well with this.
Yeah, yes, no, you can go ahead, Nishimura-san.
Okay, okay, thank you.
Yep.
I have two questions about that. The first, you explained the original system of the VSS was YAML, and it was not established. But now the new item coming, it's a GraphQL format. It is established. I just want to understand what do you mean by established language? That is the first question.
Yeah, so let me answer right away. It is established in a big community. So if you look at the GraphQL ecosystem, there are plenty of resources, plenty of tools in multiple programming languages. It is not constrained to only automotive industry. It is adopted in multiple industries. So that means that you will have a lot of tools that can be reused, right? So it's established in the sense that it is being extensively used. Yeah.
Okay, thank you so much. This is the answer. And the second question, the regarding your explanation, the VSpec will be moved to the GraphQL. Then my question is, what is any other alternative solutions other than GraphQL? What kind of alternatives you evaluate? Then you chose the GraphQL and why?
Yeah, thanks for the question. So just to make it clear, it is not that BSS will change to the graph domain. It is an optional transition if you would like to have it as a source, or if you want to do a full migration of it, is also possible. But it is not, at first sight, is not replacing the existing BSS, because this effort, this initiative is basically focused and grounded on the criteria I listed there. So if there is a member organization for which what BSS is offering today is enough, then we are well served with that, right? And then the second part of your question, basically about other alternatives, and there is indeed a set of options that are actually much more expressive than GraphQL language, that let you do also like automatic inferencing and other stuff that comes on top, like for example the web ontology language. You have also the UML ontology language. You can have JSON schema, maybe Apache Avro schema. There are plenty of other alternatives, but if you look at the criteria I listed at the very first row, we have simplicity for non-experts. So if you go for web ontology language, we have tried that in the past using directly RDF and the ideal way of solving. Unfortunately, this learning curve is very steep, and this is causing that contributors are not participating anymore. So that is basically the trade-off, was to find the balance. So we are not claiming that this language is the perfect language. We are saying that this language is satisfying most of the needs that we have to serve as this bridge between the ideal way of doing data management and what the people need in the physical layer. Yeah, because I assume if you come from a big organization like yours, I assume that you will have also several systems. Some of them might be legacy, and the company itself might have a much bigger strategy when it comes to metadata management, and possibly that will be also aligned with RDF and the semantic web standards. But if you go directly to that domain in small scale projects, in development processes, maybe this will be like boiling the ocean, right? So you will be trying to get something in the ideal shape, but the pace of development is much faster.
Okay, thank you very much. I understand GraphQL at least have the minimum meet minimum mandatory. Then you selected that, even it is not perfect.
Can you repeat the question? I didn't understand.
No, it's not a question. I understand you selected GraphQL because it meets a minimum mandatory, even it is not perfect.
Yes, that's correct. That's correct. Just bear in mind, for example, that we didn't include reasoning as a feature. So if you consider reasoning, then of course GraphQL is not supporting that, right? There are much better languages in terms of expressivity, but they all are sacrificing the simplicity. And this is non-negotiable.
Okay, you selected more the simplified way.
Exactly. That's why we emphasize the simplified approach, right? So
Yeah, actually, the YAML was really the simplified. That's why I wanted to understand why you selected the changes. But I understand the minimum simplified change, other than the different solutions.
Yes.
Okay, thank you so much.
No worries. Thank you for the question.
Yeah, thank you for the question. 質問ありがとうございます、ニロさん。So, any other questions from your side from Japan? 何かご質問ございますか？せっかくの機会ですので。ちょっと時間があと3分しかない。
じゃあ、
はい、どうぞ。
すみません、中山です。
中山さん、どうぞお願いします。
はい。じゃあ、すみません、喋りますね。This is Nakayama, Yosuke Nakayama from Toyota. So thank you very much for your insightful presentation. And I have a question for the VDM. And so recently I'm running the VSS and VSpec repositories, and I feel that in the YAML-based VSS, how can I say so? There's some nodes such as vehicle cabin door driver side, or vehicle cabin door passenger side, seem to represent the instances rather than just types or the big models. So but in the GraphQL-based VSS, should I understand that such the instance like nodes are no longer explicitly declared and a part of the GraphQL type definition, right?
That is a good observation. For the time that we had limited today, I didn't cover that example, but you are right. So current VSS is defining the instances upfront, but this is a little misleading because the instances themselves are used in the physical layer. They are important for the physical layer, but when you think of having a unique conceptual or logical model, the instances might not be too relevant to have it up front. So that's correct. So what we are doing in that regard is decoupling them in a way that you focus first on the types. Let's say you model the seat without instances, and then with the tools before creating the export, you can pass, okay, for the seat, I have in my company this model, and this model has 2 doors, it has 4 seats, it has all the instances, and then the export artifact will contain the instances you gave via the tools without needing them to be directly in the reference specification. They can be like passed as a complement, so to say. Yeah, so we are addressing that already.
Thank you. Thank you very much. So I understand that by translating by using the VDM and GraphQL, so that the COVESA is trying to separate explicitly the data, value, and model. So I understand. Thank you.
So now, unfortunately, time is almost already up. But one more question from Honda Akiyama-san in the chat. Can you answer this question, Daniel? Try to do that.
Let me see. Although VSS provides a struct type, there are no practical examples, which makes it challenging to adopt. Will these issues be resolved by VDM S2DM? I believe so. So if you ask me, my personal opinion is that yes, we need to test with a concrete example because different companies have different requests or different desires, right? But in principle, the type system in the language of GraphQL let you do that out of the box. One example is A good candidate for an struct in BSS might be the geographic location, where you expect to have longitude and latitude, for example. And this ideally has to be a standalone concept that exists without dependency of any other, right? So that you can say, okay, person is located at this geographic location. The vehicle is located at this geographic location. So you reuse the types. So this is out of the box part of the language, right? Which is to some extent doable in the current BSS via the structs, but you are right in saying that the current BSS open catalog is not, let's say, standardizing so far structs.
Daniel Akiyama-san also had a slightly earlier question in the chat about actuators.
One issue that there is no guarantee for actuator operations. That's correct. That's correct. Yeah, fully correct. I understand that misleading use is possible because the information that you are expressing in the current BSS, either an attribute, sensor, actuator, has no concrete, let's say, effect until you reach the implementation of it. So your real system has to parse that and read, and then just do something. So in our vehicle data model approach, we can get advantage that GraphQL also let you express API operations. They are called queries for read operations and also mutations in terms of insert, delete, and update. And the idea would be to also extend that to say, okay, if you model the seat, how or what kind of operations you can perform on that seat. So that is more aligned to an API specification than simply saying in plain English, okay, this is an actuator, but having no control on the final use, right?
Yeah, thanks for feedback. So now time is almost up, and so I think more questions will come up. Then so one key point or to push to every audiences. So we have in COVESA, we have the regular meeting on Thursday night in Japan time, right, Daniel? From
it is, I don't know the Japan time, but it is at 3 p.m. on Thursdays,
3
Central
p.m.
time. But
Central
this
European time, yes.
It is fixed for now. It's something that we can also discuss. If there is enough interest from the audience, we can also move to a more suitable time for you. It's not a problem.
If there is any further interest from the Japan side, so Daniel will consider to shift the time slot to the adjust to the Japan friendly time slots. This is the current situation. So if there is some interest and further questions and some comments, so please let me know. Directly let me know to Morita, and I can, and also in English and better, but also in Japanese in okay. I can translate it and directly tell Daniel about the situation. Yeah. So if there's some questions, directly communication with Daniel. If you want to do that, please let me know, and I will arrange this meeting. Yeah, that meeting. Yeah.
Yeah, thank you so much from my side as well, and on behalf of COVESA, we are willing to further discuss this topic. So we are interested in also extending this initiative and activity. If you have any suggestion or request, so the idea is here to work as a community. And if I understand correctly, in order to contribute, because this is an open project, you don't even need to be a member of COVESA Alliance at first, and we can just get it started, right?
Yeah,
so thanks
this
for
COVESA project. COVESA as a project is very open. Even yeah, you are not the member. You don't have any membership for it. This is very open. Then you can freely join, and yeah, はい、というわけで、in Japanese、そう、今日はご参加いただきまして、どうもありがとうございました。このような感じで、ダニエルと直接こういうふうなVDM プロジェクトをリードしている方から直接説明いただきました。何か他に本当にご質問等、何かリクエスト等ございましたら、遠慮なく私宛てにご連絡ください。ダニエルと直接つないでですね、こういったセッション、また開催の検討させていただきますし、本当にプロジェクト自身に今日入って、活動してみたいということがありましたら、ダニエルに私も言いますし、事務局にも言ってですね、時間をシフトして、随時レギュラーミーティングやっておりますので、そういった形でやることも検討したいというふうに考えておりますといったところでございます。今日は遅くまでご参加いただき、で、チャットに入っておりますけれども、VDM のプロジェクトの、ウィキ、コンフルも実はありまして、そちらをご覧いただければ、ミーティングミニッツも書いてあります。これすべてオープンになっておりますので、そちらをご覧ください。で、随時、今日の資料のリンクもですね、そちらにもあります。また共有させていただきますので、特にJASPER、OpenSD イニシアティブの方には私から連絡をさせていただきますし、また随時ですね、アップデートはさせていただきますので、またどうぞよろしくお願いいたします。So, thank you for your time and thank you for the joining for today. So, please let me know if you have further questions and comments and some requests for COVESA and VDM projects. Please let me know and please feel free to join this session. And also, I look forward to if you are joining to the COVESA all member meeting in Hanover the week after the next week. Then I look forward to seeing you in person. So I'm really there, but yeah, this VDM discussion will happen. It is an all member meeting. Then it will be good, nice opportunity to discuss together in person. Thank you very much for your time for today. Have a good day. Thank you very much, Daniel, and thank you very much for the organizing and the presentation. And Paul, thank you for the organizing. Taking up.
Thank you.
どうもありがとうございました。
Thank you very much.
Thank you. ありがとうございました。はい。では失礼